Okay, so now for part 2 of this, we want to see what short sales are going to change for this. So I've copied this over for client number 1, and I need to, I'll clear this off and do it again. Come here and say my return is equal to, and wait, the portfolio A and B, this disappears now. These, let me stop here, but all this doesn't matter anymore. This was just there to do the algebra to solve when you could do short sales, but the algebra breaks down when I'm trying to do no shorts, so I'm going to use solver. So my return is equal to the sum product of the weights in my portfolio and the returns on those stocks. And the weights I start with, I just start with some number, wherever that number happens to be. So I just don't even add to 100. That's fine. They'll eventually add to 100. The volatility is equal to the square root, and we're doing basically the same thing again. Matrix multiply, and transpose. So I'm taking the weights and I'm transposing them, and then I'm multiplying by the covariance matrix. Let's close parenthesis, and then I'm multiplying by the weights again, and close the parenthesis, and that's my volatility. Alright, so now I go to solver. If you don't have solver, you have to load it in. I'm going to clear all these off like we've never seen them before. And we're going to do this from two different setups. First, we're going to say a client wants a certain return. So if a client wants a certain return, and this seems like not the way to do it, but this is the way to do it. If a client has a certain return, you want to have a volatility, and you want to minimize that volatility by changing these cells subject to the constraint that the weights, so these weights add up to 1, and that the return is equal to, and let's say we have a return of 0.25, return of 25%. Okay, so, and I don't want to uncheck this. This will make all the unconstrained variables, which everything we're changing, it makes them non-negative. We don't want to do that right now. First, we want to do it completely unconstrained. So again, I'm setting the volatility to a minimum by changing the weights in the portfolio, and the weights have to add up to 1, and the return has to equal 0.25, so solve. And 25% return had a 13.98% volatility. Look at that first number for AGCO. So now I go down to client number 1 and say I want a return of 25%, and these numbers, this volatility and all these numbers should match what I have up here, and they do. So I feel good about that. So now I know that everything is correct. The formulas I put in are right. That's my check. So now I can add and say I want all of these numbers to be greater than or equal to. I can put in 0, or some people say, I want to always have at least 2%. Each stock in my mutual fund has to be at least 2%, or however you want to do that. So I put this constraint in rather than clicking this button. You can do either one as long as it's 0, but if you want something other than 0, you have to do that constraint. So I solve. And note, same return but much greater volatility, and that did not sum to 1. So let me make sure that constraint comes in, and it didn't find a solution, so it can't make that happen. So let's change that. Let's do this again and read what it says. Solver could not find a solution. Okay, so sometimes it just doesn't work, that you can't do that because we're constrained. So let's change this and make it 15%. Okay, and solve. And now it can work. So that adds to 100%. When you can do short sales, you can be anywhere on this line. So I can be anywhere on this if I can do shorts. If I can't do short sales, I can't. And what's the highest possible return I can get? Look at this. I should have never tried 25%. The highest possible return I can get is 20.27, and the lowest possible is 4.6. So you got to keep those constraints in mind, and I didn't do that. So Solver said you can't do what you're trying to do. All right, the other way to do this, the client wants a certain volatility. So let's first see what's feasible, and we'll say let's set our volatility to a minimum, and the only constraint that we're going to have is that they're equal to 1. So first I want to find the minimum variance. So take the volatility, set it equal to a minimum by changing these cells, subject to that all adds up to 100%. Click OK. Some of these are going to be negative, that's fine. Let's go look and see what, when we're unconstrained, we have a return of 21.61. Look at all these weights, and then go back up here, 21.64, I said that wrong, and all those weights are the same. So I feel that Solver is working correctly. For that, I can add the constraint that all of these have to be greater than or equal to 0, and then I can solve. Okay, so my minimum volatility is 14.33. So when I go back through here again and I have a client that wants to have a certain volatility, it's got to be at least 14.33 or it's not going to work, because that's the minimum we can get. So I say a client wants a certain volatility. I take the return and say set the return to max by changing those cells. They should all be greater than or equal to 0. I'm going to get rid of that constraint right now. So I'm going to delete that. And I add the constraint that the volatility, that this number has to be equal to at least, let's say 0.17. Okay. So we have a volatility of 0.17 is what we want. So we set the return to a maximum, we solve. And just to double check, that gives us a 31% return. Come down here to client number 2. Say I want a 17% volatility. Returns 31.12 minus 52.38. That matches up. It's off just a little bit because that return is not exactly 31.12. But if I were to go here and say this is equal to this number, no, that's not what I wanted to do. Hang on, did that wrong. This 17, it probably didn't get that 17 exact. It just got close to it. That's when we're off just a little bit. Yeah, it didn't get exactly 17. So Solver doesn't always, this is a good teachable moment, Solver doesn't always solve the problem exactly to all the decimals you may think it has, but still that's good enough, close enough for us. So let's go back to Solver, and now we want to add the constraint that these all have to be greater than or equal to 0, and solve. And click OK, and the return goes down because we're now constrained. Alright, one other thing with Solver, Solver doesn't always work. So it depends on where you start. So with these starting values, and I can use a different method. So if I use a different method and have different starting values, I may wind up in a different place. And see, that one it didn't work for because I changed that. So it's not a perfect algorithm. And again, it didn't work there. So if we stick with this one, that seems to work. But note, the number was a little bit different this time than it was before in those last decimal places. So hopefully that's good enough to get you going where you can figure out how to do all those different things. And I hope this worked because the power just went out. So hopefully I won't have to redo this.